Welcome, 8th graders. This is Big Idea B, question B3 specifically. These are all of the different mineral properties that we reviewed in class. We did demonstrations of, and ones that you've been practicing and using actually in class. So while it's probably better for you to actually do the mineral property tests with your hands, this might be helpful if you're trying to put together your ISM. So first set of mineral properties that we tackled on the first day was hardness, color, and streak. Remember, every mineral has its own unique set of physical properties because of the atoms that make it up and the arrangement of the atoms on the inside. So one of the first things we learned was hardness, and the definition of hardness is the resistance of a mineral to being scratched. It's all about the scratching. Soft minerals are easy to scratch. Of course, hard minerals are not. And you can think of the hardest mineral out there pretty easily probably, and that's diamond. One of the softest ones would be talc and graphite and things like that. And then there was this guy named Frederick Mohs who came up with a scale, a 1 through 10 scale for hardness, which is known as the Mohs Scale of hardness. And this is something, again, you've probably spent a lot of time getting to know in class as we've been practicing these different properties. So a 1 would be a very soft mineral, a 10 would be very hard, and we've been using all of these very common items here in our classroom to help us figure out how hard a mineral is. So your fingernail is a 2.5, a penny is a 3.5, iron nail is a 4.5, glass is a 5.5, and a streak plate is a 7. And so when we scratch minerals onto these things, we're able to narrow it down and figure out what the hardness number of any given mineral might be. Another property, of course, is color. And color is a difficult one because sometimes it's very helpful and other times it's very, very unhelpful. And those of you that have been identifying minerals, you know what I'm talking about. Quartz can come in just about any color. And yet there are some minerals that are very distinctive for their color. Olivine is a good example of that. Olivine is always a distinctive green color. So it's something you have to be kind of careful of and take it with a grain of salt because sometimes it points you to the right answer, sometimes it points you to the wrong answer. Pyrite and chalcopyrite are an example of being careful with color because they look an awful lot like each other when it just comes down to color. But if you use some of these other properties, you can really get the name very, very easily and very accurately. So another one would be streak. And of course, streak is the color of a mineral when it's been crushed into a fine powder. We use streak plates for that. I know, pretty amazing that we use a streak plate to figure out the streak of a mineral. So basically what you do is you grind that mineral into the streak plate, you crush it up into a powder, and the interesting thing is sometimes streaks can have a very distinctive color. Many of them, though, turn out to be white or clear. Although, however, there are some minerals that have very distinctive streaks. Hematite is one. It's always a rusty red. So those are the first three properties. Let me show you the next three that we handled on the next day after we practiced a few of them. Here we're talking about three more. So now next we're looking at luster, cleavage planes, and specific gravity. So when it comes to luster, luster is the appearance of a mineral, and it comes down to two different choices. You either have a metallic luster, which, well, means that it's metallic looking, or non-metallic luster, which is anything that does not look metallic. And some of the ways to tell whether or not something's metallic, if you look at it and you ask yourself this question, does this look like it's a piece of lead or steel or iron or gold or silver or anything like along those lines, copper? Those are all metals. The other thing you could do is kind of heft it in your hand, toss it in your hand up and down a couple times gently. If it feels heavier than it normally should, that's a really strong indication that it's a metallic mineral and therefore has a metallic luster. And most minerals that have a heavy weight to them, feel heavy for their size, are going to have a metallic luster. Cleavage planes are probably the most difficult but also the most helpful of the properties out there because some minerals break along really smooth flat surfaces or planes, and those of course are cleavage planes. So it happens when minerals are split along smooth planes, and it literally happens between the atoms in a mineral, and it's directly related to the atomic structure. These minerals have weaknesses in them, and it comes down to how the atoms are put together. And if you have a weakness, well, just like the old saying, a chain is only as strong as its weakest link. So when these minerals have weaknesses, all you have to do is hit them gently and they'll break along those weak planes. And that's why we have cleavage planes. Minerals that don't have any weak planes, they're equally strong in every direction, well then they just break randomly instead of in some sort of pattern. So we talked about this in class. You can have a mineral like the one up here which has no cleavage planes. It's just a rough, uneven surface, and all these rays of light coming in just bounce back in random directions. Whereas here you have a mineral with cleavage planes, and so they all reflect all at once. That's how you get that characteristic flash. And this mineral down here shows a phenomenon known as stairstepping, where you actually do have cleavage planes. Here you have all of these cleavage planes. They're all parallel to each other. It's the same cleavage plane showing up in lots of different levels, but it's all the same one because you notice all the arrows end up reflecting back and pointing in the same direction. So you'd get a flash even with something like that there. So then we did a few demonstrations in class, which of course I can't do for you here over the computer, but I can share with you some helpful tips. If you're looking for cleavage planes, you should look for regular shapes. Minerals that have squares or rectangular shapes are a really good indication. Minerals that look flat and have smooth surfaces, great for use there. When you see flashes of light, as opposed to light kind of moving across the surface. If you can get the whole thing to flash all at once, that's a really strong indication of cleavage planes. Looking for that stair-stepping that I mentioned in the previous slide. And also looking for something that looks like pages. If a mineral looks like it literally is made out of pages in a book, that could be one cleavage plane repeating itself over and over. And then the last one from this set of properties would be specific gravity. That's all about density. Dense minerals have a high specific gravity. Low density minerals have low specific gravity. Most minerals are average, as you might expect. And if you recall in class, we either deal with average or high specific gravity minerals. We don't really have any low ones. They're very rare. I don't have any samples myself. Most minerals end up being average. Some of them are high. In fact, most of the minerals with high specific gravity also have a metallic luster because they're made out of metal. All right, that's our third set of properties. The last set of properties is actually really short and sweet. These are the last two tests, and these are really helpful tests if you happen to think that you have something like magnetite or calcite. So we have the magnetism test and the acid test. For magnetism, some minerals are magnetic, and because so few of them are, when you actually do have a mineral that's magnetic, it gives you a really good strong indication that you have magnetite. But be careful, hematite can also be somewhat magnetic. But it's very, very helpful. The acid test, if you use the diluted hydrochloric acid, then when you drop it onto a mineral like calcite, it will fizz. And so that's really helpful too. If you think you have calcite and you have a mineral with 3 cleavage planes and hardness of 3 and you're thinking it's calcite, try the acid test. And if it fizzes, you definitely know for sure that it is in fact calcite. So those are the last couple. That concludes all of the B3 physical properties. There's a lot of properties, but when you use them all together, it's super helpful in figuring out what mineral you actually have, because every mineral has its own unique set of properties. So it's kind of like a mystery novel. If you can eliminate all the other suspects, you're left with only one possible choice. So that concludes question B3. Good luck to you on your ISN, and we'll see you on the flip side.